Right now, developers using AI tools like Claude Code and Codex are seeing development speeds that used to be impossible. By offloading basic syntax generation to an AI, complex software architectures are assembling at record pace. But that velocity comes with a hidden cost. It relies on a developer trusting the code the AI generates without verifying every line. That trust introduces a critical, almost invisible vulnerability deep inside your system. This diagram illustrates exactly how that vulnerability gets exploited. Recent security demonstrations prove that AI coding agents are highly gullible. When an AI processes data, a malicious disguised instruction can hijack the clean input and trick the agent into executing it. Security researchers call this a poisoned repository. Looking closer at the diagram, you can see how a normal-looking open-source project might harbor hidden commands. When the AI reads that repository, the single poisoned node tricks the system into pulling those destructive commands and replicating them across your entire network. The AI itself isn't acting maliciously here. The breach happens when a developer bypasses standard security checks to save a few minutes. Pasting unread, AI-generated terminal commands directly into a live environment means you are actively trading the structural integrity of your codebase for raw speed. This tension is the reality of modern software engineering. If you don't verify what the AI writes, your fastest development tool immediately becomes your organization's biggest security liability. Fixing this requires a change in how we approach coding. The AI acts as the engine generating the speed, but you must act as the brakes. That means committing to a 3-step framework: review, verify, and then execute. The first rule of this framework is straightforward. Never run an AI-suggested terminal command that you haven't read. Your own comprehension of what that command does is the ultimate security layer, and it cannot be bypassed. The second rule requires you to manually vet sources. This matrix shows what to look for before letting an AI clone an unknown repository. You evaluate 4 metrics: total stars, active contributors, documentation quality, and community activity. Tracking this filters poisoned projects. Notice how, as contributors and activity drop to 0, the system blocks the repository's data from entering your pipeline. Chasing speed without vetting your external sources is a fast track to a broken system. Slowing down to verify where your code comes from ensures your long-term progress won't be derailed by a sudden security breach. That brings us to the third rule. Before you paste any AI-generated script into your live environment, you have to understand its exact function. This split-screen comparison shows exactly why auditing matters. On the left, you see a clean, highly readable block of standard logic, but on the right is what malicious execution lines actually look like: dense, obfuscated code hidden within the script that you must isolate and strip out. This auditing process is the modern standard for DevOps. It comes down to 3 non-negotiable steps. You verify the logic visually, test in an isolated sandbox, and only then do you deploy. Adopting this workflow reinforces the core philosophy of working with intelligent agents. AI tools are engineered to do the typing. You are hired to do the critical thinking. By mastering these verification rules, your role shifts. You stop being a vulnerable code typist and start serving as the final audit for your organization's security. Beyond immediate security threats, there's a larger question hanging over the industry: the idea that AI coding agents will eventually replace human software engineers. The reality of the market is specific. AI itself will not replace developers. However, developers who know how to securely manage AI systems will inevitably replace those who refuse to adapt. Because AI is so efficient at handling raw syntax, the definition of what it means to be a software engineer is shifting upward. Typing out functions is no longer the primary job. This skill hierarchy starts with machine-handled syntax generation. The human role ascends through prompt verification, system design, and peaks at product architecture. Transitioning to a network layout, one human node now oversees multiple AI agents, orchestrating a complete digital ecosystem. Secure AI building practices are mandatory training for the software landscape of tomorrow. Preparing now ensures you have the skills to manage these systems effectively. By mastering the tension between automated speed and manual security, you move past the limitations of manual coding. You elevate yourself into an architect capable of building complete software products, fully future-proofing your career in the process.